Hey, it's Marky Popsis. How's it going? Okay, I think we're ready to start. I mean, I hope the audio is good anyway because I just changed some settings. Yeah, I'm good. Yeah, audio is good. Okay, nice. Okay, cool. So how's it going this Saturday morning? I mean, that's how it is on the side. Yeah. Yeah, here it's like a sunny day. I'm gonna go out for like a bike ride in the afternoon. Yeah, the sun is out, so yeah, it's gonna be a very good afternoon, I believe. Yeah. So we're doing Rust. Yeah. Brainstorming about your cookbook IO project. Nice. Cookbook IO. What's that about? If you don't mind sharing. Put this here. Yep. CIS input, physical cookbooks output. Okay, so input, and then your physical books output is recipes and all metadata. Interesting. Yeah, that sounds pretty interesting. So it says your gastronomy, technical background, history, evolution. That sounds really interesting. I don't think I've seen something like that. Yeah. It sounds pretty interesting. Recipe evolution. I mean, for me, I really like cooking. I mean, not like I always liked it. I think I was forced to like it. So recently, I've started. I think my goal is just to reduce the amount of time I spend cooking. Yeah, but then I was also making food that's nutritious. So food that I can make in maybe like 15, 20 minutes max. That's it. So yeah, it has made me like try out a lot of different recipes. Yeah, and different things and seeing how I can bring down the time but still retain nutrients and everything here. You want to go from stochastic recipe generation to authentic, reduce the amount of time with your instant pot. Ah, is that also like a recipe? Oh, pressure cooker, slow cooker, all in one. Hmm. Okay, that sounds cool. Right. Okay. Maybe we get started. I'm probably gonna do a few hours here today, and then you see. Yeah. So previously we so again like we're going back to Rust. We wanted to like get a hang of the syntax of the language again. I left it for some time. I was working on a project before, so the goal is to finish Rustlings, go through the Rust book, and then like get back to building the app that I was working on before, and also other cool things in Rust. Yeah, we we left off. We're supposed to pick up with error handling, I think. So that's the chapter in that's the exercise in the Rustlings project. Yeah. So now we have to look at error handling. Um, so let's see. I mean, we're just gonna run through because we already have. I mean, we already know how this works. We're just trying to do like a refresher. If something stands out, we dig a little into the standard um, or standard reference. Maybe also like we have a playground. We can use playground and stuff. So yeah, that's the idea. Okay, so this is the result in num. I mean, if the music is too loud, I can stop it while we're reading the book, or like just going through. Yeah, or maybe I should actually right now just pause it first. Okay, so um, so the result enum. We have the so this is an enum over generics type, the actual type, and then the error here, like generic T and E here, where it has two arms or variants, okay, which takes the parameter, which is the generic type here, and then also the error, also generic. And so when there is the okay represents when this when there's no error, but the error variant also it will hold the error, the result, the error that's there. We can use this for opening a file. Go file open, which returns a result, and we can match on the result, yeah, and process it like that. This is using three different match blocks, which we can use the short circuit operator or the question mark operator to make that nicer. We'll see that in a bit. It says the alternatives to using match with result. What are the alternatives? It's using if else. Oh no, it's using what are the alternatives here? Oh yeah, it just using unwrap or else. Okay. Unwrap or else. So you basically provide an error. Unwrap or else takes an error function, right? Yeah. Yeah. Takes error and then panics, yeah. So it will return T or that. Okay. And then short shortcuts for panic on error, which we can use with unwrap. And instead we can use unwrap like this. Or we can also use expect. Just that unwrap, you don't provide the error message, the message, but for expect you provide the message to it. And we can also propagate. What's this? Am I having trouble with my? Oh yeah, I think I was having some trouble with network before. But yeah, hopefully it's back. Propagating errors. How do you do that? You can return the error to the caller. What? Oh yeah. So here you're returning the result. Yeah, this is pretty straightforward. What else do we need to see? By the way, the error comes from, okay, this error is like, I think we have multiple error types. Rust standard reference. Is it? No, not okay. Or not the standard reference. Rust. What's it called actually? Is it the library? Yeah. I don't want the source code. Yeah, I think it's what we're looking for. Yeah. So error. Yeah, so we have IO error. We even have FMT error. But this is a trait that I think we should be concerned about. Yeah, the error trait. So it represents the basic expectation for error values as values of type E in result in the result enum. Yep. Okay. So errors must describe themselves. Blah blah. Implementing the error trait only requires that debug and display are implemented too. Right. So we can implement the error trait like here. This is read config error. It's just a struct, but we can implement error trait on it by this attribute would automatically take care of debug, yeah. And then this is how we would implement the display. Yeah, this is how we implement display traits. So we do implement that for our struct, and then the method we implemented. This is going to return result. So okay, that's just how to do it. Okay. So yeah, that's error, and I think I was just going to I wanted to pay attention to the fact that you can have multiple error types. The same way you have, I think we also have multiple result types. Yeah, I recall from what I recall, but we see. This is a short circuit operator. Yeah, which would automatically short circuit this in this case. So file open returns a result of a type and error. Yeah, and when we use a short circuit operator, what is returned has to match the return type of the function. Yeah, so because this is returning results of a type string and IO error, and file open returns would either give us a string in this case based on what's here, or to give us a yeah, it's going to be a string in this case. I think. I mean, it would in any case take the type that is take a type that is set as a result here, yeah, or as a return here, and then whatever error that will be returned from here, it's actually we need to see what file open returns. I think, yeah, it's an IO error. File open should return an IO error. File struct, it has the open, which returns a result that can have a file, just a file. So what about the error? Or is this, wait, hold on. Okay. So this would actually be fine, even if there's no error returned. Okay, so file open is just giving us the file. Errors. The function will return an error path if a path does not exist. Yeah, but why are you saying? Oh wait, hold on. Let's see. What's this? Is this a result here is not it is actually a type alias. Yeah, it's basically yeah, you're basically aliasing the entire thing. So like result of a type and error. Yeah, so it's like a shorthand for that. Okay, so this is just a type. So it's a specialized result type for IO operations. It's broadly used across stdio for any operation which may produce an error. So it's just to avoid writing out IO error directly. And so otherwise a direct mapping to result. Okay, so Rust style is to import types directly. Aliases of result are often not. To make it easier to distinguish between them, result is assumed to be std result. And so users of this alias will generally use IO result. Okay. Instead of shadowing the prelude. Examples. This is an example. A convenient function that bubbles IO result to its caller. This, so you bring IO std IO into scope, and here you are returning the type result, and say that it's return a string. Okay, so well, we know that this can be string or error, so that's what's going on here actually. Is it here? Where were we? Yep, here. This result here is the one from the prelude. So yeah, which is result std result. Yeah, that is that one there. Yeah. So because we don't have any we're not bringing the scope here, so we know this is coming from the prelude. Yeah, but what is a bit strange to me is like why I mean, this is going to, this only returns, wait, oh, okay, yeah, I remember, I recall. We were saying that, where is it? Yeah. So open file open returns the result alias and file. Yeah. So it's an alias which is a short for, what's that? Yeah, which is a short for result and error and IO and yeah, IO error. So where did, I think I just go there. Yep. Result and IO error. This is actually IO error. Yep. Okay. So yeah, that's why this works. Okay, and then we create a string, a new string in memory on the right, and assign it to a mutable pointer here, and we call read to string, giving it the username. Read to string, what does that return? I think it's also going to return a result of string, and should be IO error as well. The file has open. Read to string is, I think we saw that. Oh no, wait, hold on. Open, and then we saw read to string. If you only need to read, so this gives us a file name, but if you need to read the file contents, you should consider read or read to string. And read to string is okay. This is a public function on the module, I guess. stdfs module. Is there anything else? Yep, it's on the module. It's on file system module stdfs, and it has a couple of structs like these ones here. Has some enums. That okay, and then what? Yeah, modules of course, and where were we seeing file macro? Okay, these are the functions that are in the module, including read directory, also has exists, and read to string. Okay, let's close this. Yeah, read to string. So the public function reads the entire content of a file. The convenience function for using file open and read to string. Read to string is also in std. I think it should be in the file system as well. Read to string takes you can call this on the file, I believe, because it takes immutable refers to self, and you give it a buffer or like a string mutable buffer, returns results or use size. Yeah, you call it on the file. Yeah, f dot read to string. Okay, that's clear. And yeah, I think we wanted to see what this returned. What's it? Yeah, it returns result that's a string, and it's a type. Yeah, it's the result type. So, and this gives us the okay Yeah, we just short circuit to the OK if there's no error. Otherwise, it will automatically get the error and return that there. Okay. So it's, mm, so it's talking about what this question mark operator that is placed after result value defined is to work in almost the same way as match expressions. If the value of result is an OK, value inside the OK will get returned to the expression. So it's the value that we're dealing with here. Yeah. And the program will continue. If it's an error, the error will be returned from the whole function, as if we had used return keyword. And the value gets propagated to the calling code. So now there's a difference between match expression and the question mark operator. What is it? So error values that have the question mark operator called on them go through the from function. Yeah, I think I recall this part. Go through the from function defined in the from trait in the standard library, which is used to convert values from one type to another. When the question mark operator calls the from function, the error types received is converted into the error type defined in the return types in current function. So it's useful when a function returns one type to represent all the ways a function might fail, even if parts may fail. Okay, so it's like wrapping like global errors or something. So it's given an example here. Yeah. Basically saying you have to implement the from trait on the error, that's the parent error in this case, for your custom error, so that it knows how to go from when you say from, it knows how to create an IO error from an instance of your error in this case. That's hey ICS Boix. How do you say that? This is Boix. So good afternoon. Yeah. How's it going? Yeah. Okay, so that's about the from. How do you say that? It's ISC is okay. Okay, ISC. ISC. Okay, but it's like ICS Boix. That's there. Okay, ISC is okay. Cool. Okay. I mean, it's a Saturday morning. Yeah, everyone is chilled. Okay. Welcome. We're going through errors and result type generally. Yeah. Um. Yeah. So. Okay, so that's the difference here between the match and using the question mark operator. When we use the question mark operator, where it's basically going to call the from function of the from of the from trait. Yeah. So basically, there has to be an implementation for it for this to work. Yeah, and it's very useful for us to for example, like with error handling, where we can have like a catch-all error type or struct, and then we just need to implement the from trait, so it knows how to go from our error to the generic or catch-all error compatibility. You just did that for one of your projects. Yeah, nice. I mean, I recall a couple of months ago, and I was working on a project too. Like, I mean, I played around with it too. So yeah, it's pretty You can. I mean, I was getting too lost in it, like too deep in it. I know then I was trying to write most of it by hand, even though I think there was like a library I could use then, but I was like, no, I'm not using the libraries. I just wanted to make sure that um I really got the hang of things there. Yeah, it's cool. Yeah. Also, that's like okay, the example code. Um, let me see. Let me just go there at once. Right? Yep. Okay. Black hole here. So you have an enum as these variants. Rep. Okay. And then yeah, and then you implement the from trait. So to go from your enum now to a U8. Okay. Oh yeah, I should click the zoom. Yeah. Okay. So it's I guess too small. Yeah. Okay. Yeah. Okay. So basically, wait, hold on. Um, when you do a from, I'm when you're implementing from trait after I done yeah, I'm gonna scroll down. Um, so basically, you have a U8 value, and then you're matching the value, and then you're going um to the enum variant here. But actually, when you implement from trait, you're basically specifying that your program knows how to go to this type here, which is the U8 when it has this in this case. I mean, it's the inverse of into, right? So there's the into trait as well. Yeah, from and get auto into. Yeah, okay, okay. And then you also implement um the from trait on stream error. Where is stream error? Okay, stream error is a struct that is here. Okay, is that a dynamic as well? Okay. Anyhow error. Okay, use anyhow library here. Okay. Mm. General failure. Right. So you also implement for I error for stream error. Okay. Yeah. I think you yeah, so you're using so you have debug and display for stream error. Mm. Yeah, that allows you to go to I error. Yeah. Okay. Nice. So I guess having this now, I mean having this file or this this allows you to handle errors generally in your entire program. Like this, just have everything in one place, and I mean you would be able to handle most of it, I believe. Unknown, yeah. And the catch-all here um is hold on. is your rep error, and then you can say these, yeah, these ones. It can be any of these, and then what is okay, and then you can also SOC 5 RFC. What you mean? There's like the request for comment, or like an RFC that you basically implement this from? Is that what you mean? So you're basically following a standard implementation, or like a specification for this? Yeah. Okay. Let's see. Yeah. I think I stumbled on your stream. I think it was 2 days ago, and I saw this somewhere too. Yeah. Okay. Right. Okay. It's cool. Yeah. Um. Yeah. So let's see. I have one thing to clarify with this uh dude here. Wait. Oh, come on. Why does it not do that? Oh yeah. Oh no. Oops. Yep. Okay. Let me just say about I want to ask it. I want to ask it about I want to ask it about how the from and into traits basically behave, right? So about Rust, let's say error handling. Um, when I implement, oh no, let's say about Rust, short circuit operator. Yeah. Mm-hmm. It knows to go from. It knows to target, yeah, an error type based on the from trait, right? From trait implementation it has. How to reason about this? Does this mean I know how to go to target type from custom type? Yep. So yeah, I'm just trying to validate my my reasoning of the from trait, and I mean, like, yeah, exactly, from trait implementation, how exactly it works. So it says the mental model is correct. What question mark operator's logic? When we write this result T and E, so if it were like a match, the way it would be is okay val, then go to val, and then if it's on the error, it should return right. Convert an early return. Hmm. So the key is, yeah, it converts the error using whatever from implementation exists. Okay, yeah. So I know how to go from custom error into target error. Okay. Yeah, okay. I wrote it as like go to target error. Okay, so yeah, from, and then no, this is not correct. This is not correct. How do you mean? How do you mean from? You wouldn't have custom error here. What you'd have here is no. This is not right, yeah? So it wants to show a concrete example. Wait, before I look at that so-called concrete example he's talking about, if I have IO error, or if I have like IO std IO error, yeah, and I have my own error type called custom error, yeah, from would look like um, yeah, implement from, and it would be std IO error, yeah, for custom error. It's a generic implementation from T for some error. Yeah, but what did, yeah, exactly. So for some error, where some error is, yeah. So, but then, so this is correct, but that's not what it said previously. I mean, like up here. Um, okay, so, but anyway, I guess that's flip. But this is what, um, so this here is like the generic error in this case. So it's a generic implementation for some error. Yeah. So, and this here is my error in this case. Yeah. So, given this, wait, let's say, given the from function, does it mean the conversion isn't exactly using the from trait? But maybe another trait like into? Because what I specify here is you know how to go from yeah, you know how to go from a generic error like std IO error to my custom error. But you see what I'm asking about, right? ICS point. And it feels backward of press, but actually correct. What do you mean? So I do from stdio for my custom error. Okay, read it as custom error. so you said I should read it as what custom error knows how to be constructed from a TDI error. From function lives on the target type. Custom error, not on the source. Yeah. Yeah, because you cannot modify the source one. You can't change the standard library in this case, but what you can change is yours, okay? So returns custom error. Called as custom error from IR. So custom error is the caller. Into is just the mirror. Into is the same conversion, just called from the source side. So yeah, if you stream on my, if you're on my stream, ping me. Ah, okay. Yeah, I think that was it. I think when I was on your stream, I think it was Russian or some other language. Yeah. So I couldn't really stay. Yeah, I'll ping you when I join your stream. Yeah. Okay. Cool. But here, so it says Rust gives you the into free whenever you implement from. Yes. Directly. Same conversion to perspectives. I don't. I have the. I mean, I feel like this is actually using into for this conversion, not actually from, because it doesn't make sense to me. Yeah, I know who holds it. That's fine. Yeah, because like, look, the definition here is where's that even? I think we were seeing it. Was it? Where were we seeing the from? Trait, or maybe it's like. No, we're looking at, I don't even know where we're looking at again. But yeah, when you have, okay, like if we even go to this you shared, right? If we go here as well, I mean, you're saying, you're specifying, so you have an enum rep that has this variant, and then you're specifying, you're implementing the from trait for our type here, or our enum here, and we're teaching the compiler how to go from, or how to, yeah, exactly, we're teaching it how to go from this type. Yeah, I can do u8 into to get rep. Yeah, yeah, exactly. But I'm saying that, but yeah, but I think what I'm looking at here is how the question mark operator works, because it's saying that it does the automatic conversion, and it's because the reason it's possible is because from trait is implemented, but from trait specifies how to basically create, or how to, yeah, how to go to this type, the rep from u8, from u8 here. But so I guess, so because we get into for free, like because we implement this, I say that it's into that is used, but not exactly the from. So okay, well, in a way, it's related, but I think that's my mental model for this. Yeah. Okay. But if I want to read this, I'm teaching this how to go from u8 to this type, or to rep in this case. Yeah. Okay. I mean, we see we see we validate this mental model as we go on. Anyway, where do we leave off? let's see if there was any more mentions of this question mark operator. Um, okay. So what else? Oh, it's talking about something that is pointed here. Oh yes. So this error, there's an error here, and it's because main method here, or the main function here, doesn't, it returns the unit type. So yeah, I think that's what is mentioned here. To fix the error, we have two choices. One choice is to change the return type. The other choice is to use a match or one of these to handle the error. Okay. So here, the question mark extracts the string slice. We'll call lines.next, and then I think this probably gives us an option, I guess. And we can call chars on that string here. Okay. All right, that's fine. Note that you can use the question mark operator on a result in a function that returns result, and you can use the question mark operator on an option in a function that returns an option, but you can't mix and match. Yeah, yeah. So if we had something that was question mark is expanded to return error type. Yeah. Yeah, but it says we can't mix and match. So what did he even say that? Yeah, we can mix and match. So basically, if we have a function that returns, so if our function generally returns a result, and then the operation we're doing inside the function, let's say it has an option, we would make sense to, I think the method is called transpose. Or is it transpose? To go from, how do you go from a result to an option? Probably it's yeah, I think it's transpose. Transpose the result of an option, yeah, to an option of result. Oh, okay, result of option. Okay, this is even when it has okay, that's transpose, but that's not what I was looking for actually. I think it's like to convert a result to an option. I think there's a, is it okay? Need to match return type. Is it okay error, or is it like, I think there's an okay something. So if you have a result and you call okay, yeah, so it converts a result to an option. Okay, I think is what I was looking for. Yeah. Okay. But if you had an option and you wanted to go to a result, what was that? I think it's okay or yeah. Okay. So the transformation. So we have so we can do transformations here. We can do, if I have a result, we call okay to go to an option of t. If we had an option, we call okay or. Yeah, it makes sense with the or because we need an error, right? So yeah, which makes sense. Okay or. Right. Wait, why don't we have okay or takes evaluated? Okay, anyway, let's not dwell on that now. Okay, so this is about using like a smart pointer. I think this box, yeah, box is called a smart pointer anyway. Yeah, I think I remember that part. For the main, yeah, we can do that one to handle this one here. So this allows us to, this is like the catch-all thing we talked about, like generic error. So this one example of using it with the box type. Um, an error is from, I think error is standard error, I believe, right? Error should be, yeah, it's STD, error. Okay. This is like a, it's just a place to quickly write those programs. I think we're almost done with this page. Yeah, let's see what's next. Panic. This is probably still on. Yeah, this is still on error handling. Yeah, I think we need to look at panic because it's part of error handling. So basically, all of this here is talking about when we call panic, we are not able to recover from the error, but it makes sense for us to be able to recover, right? Or at least to be able to handle that, especially if we were dealing with a library or we're writing a library. We probably don't want to do panic. I think that's what this all is saying from what I see. Therefore, returning result is a good default choice when you're defining a function that might fail. So it's telling us why we shouldn't, why would we want to just panic? Yeah, makes sense. Examples when you have like prototype code and tests, when you're writing an example to illustrate some concept, including robust error handling can make the example less clear. So it makes sense to just prototype with unwrap, expect, like that when we're prototyping or in our tests. One of the things I like about the Rust book is it sort of shapes your thinking as well. Like it tells you, okay, this is how you should reason about the language too. Okay. So when you have more information than the compiler, it would be appropriate to call expect when you have some other logic that ensures that the result will have an okay value. But the logic is not something compiler understands. So these are just like reasons why we should want to call expect. Yeah. So it's basically saying that it's logically impossible to have that failure in this case, but the compiler doesn't understand this. So it's okay to say expect here. If we ensure by manually inspecting the code that we will never have an error variance, perfectly acceptable to call expect. Okay. Yeah, in this case, we can see that this is a valid IP address. So we can do this because we know it's always going to be valid. However, it's recommending to always return a result. All right. So guidelines for error handling. It's advisable to have our code panic when it's possible that our code could end up in a bad state. A bad state is when some assumption, guarantee, contract invariant has been broken. Bad state is something that is unexpected as opposed to something that will likely happen occasionally. Okay. So if someone calls our code and passes in values that don't make sense, we should return an error if we can, so that the user of the library can decide how they want to handle that. However, in cases where continuing should be insecure or harmful, might be better to call panic. Anyway, okay, that's fine. When we expect failure, we should just return a result. Okay. The same thing is saying there. So it's saying that having a lot of error checks in all of our functions could be verbose and error and annoying. So we can use Rust type system and type checking done by the compiler to do many of these checks. If our function has a parameter, as a particular type as a parameter, we can proceed with our code's logic, knowing that the compiler has already ensured that we have a valid value. For example, if we have a type rather than an option, our program expects to have something rather than nothing. So our code then doesn't have to handle two cases, sum and non-variance. It will only have one case for definitely having a value. Yeah, so it's talking about input parameters now. Okay, so this is a reason why we don't want to use option as input parameters or input arguments to functions. I mean, this is I think in languages like in JVM, for example, or Java, like it's one of the known things. I think even the standard reference talked about not using optional there. That's what it's called, at least, for input for arguments to functions, because it just makes it very verbose. Because you have to handle multiple cases. Yeah. Okay. Custom validation. Custom validation. Let's see. Um, so it's talking about in the chapter 2 where we asked our user to guess a number between 100. We didn't validate the user's guess that it was between those numbers before checking it against our secret number. So now we want to, so let's say we want to validate that. And then it says, we only validated that it was positive. In this case, consequences are not very there. Our output of too high or too low is to be correct. So let's say we want to enhance this now, okay? We want to ensure that the user's guess is not out of range, right? One way to do this would be to parse the I32, would be to parse the guess as an I32 instead of a U32. Okay, so to allow negative numbers, yes, and then we check for the number being in the range. Okay. I mean, this, yeah, this is okay, but let's move on. Okay. So it's talking about an ideal solution. So it says having a check like this in every function would be tedious, yeah. So we can make a new type in a dedicated module and put the validations in the function. Make sense? to create an instance. I think error handling is very important, so it makes sense to actually spend time to do it, because if you do errors well, then your program will be okay. So talking about making a new type in a dedicated module and putting validations in functions to create an instance of the type rather than repeating the validations everywhere. So now we define a guest type, and then we implement a way to create a new guest. We give it an i32 value, which we parsed from the user, and then we can validate this here. And when everything is fine, we return the guess. And here we also have a public. These are two public functions. Yeah. One to give the value out, one to create a new one. But here we're panicking. Okay. Okay. All right. So that's fine. I think we're done with this here. I think we're done with error handling. Oh wait, then there's generics as well. Probably that's where we are now, I guess. Yep. Wait, sorry, did I just... Okay. I think it's slightly different actually. This is generic data types. This is generic type traits and lifetimes. Okay, so it's a different one here, but oh yeah, so here. So now generics. So we have what, largest i32 function that takes a list of that takes a reference to i32 array and then returns a reference to an i32 value here. The problem with this, I mean, what this is trying to show us, the problem with this is this is largest i32, but then we also have largest char, and we're writing the same sort of function multiple times. Yeah. Okay. So two functions that differ only in their names and in the types of their signatures. So now we want to make this so that we can use the same generic function instead. So that's the motivation for generics. It's not like we cannot. I mean, we don't. I think some languages don't even have generics. Yeah, and they do a lot of cool things with it. So, yeah. But this is just the motivation for it. Okay. So we want to parameterize types in the new single function. Just like we did for the value parameters to the function. Because in this case, we said we just said, oh, this is i32, yeah? And here as well. Okay. So we can use any identifier as a type parameter name. We use T because of convention, yeah. So when we use a parameter in the body of a function, we have to declare the parameter name in the signature so the compiler knows what that name means. So yeah, just like parameters, when we want to use just like parameters, if we want to use them in the body of a function, we have to declare the parameter name in the signature. Similarly, when we use a type parameter in a function signature, we have to declare the type parameter name before we use it. So to define the generic largest function, we place the type name declaration inside angle brackets. So first, this is the definition, and then before we can use it. Okay, so this is the signature. So we define this, and then we can use it. We read this as the function largest is a generic over some type t. This function has one parameter named list, which is a slice of values of type t. The largest function will return a reference to a value of the same type t. Sounds very textbook like. It's nice. Okay, so we define a generic function, and of course define or declare the type parameter here. So yeah, it's saying that this will not compile. And the error we get is saying that cannot binary operation. I think we're using this cannot be applied to type reference to t. Okay. Yeah, because this we define it as this, so it creates a reference. Consider restricting type parameter with a trait. Okay. The text help mentions the help text mentions partial odd, which is a trait. I'm going to talk about traits in the next section. But for now, we should know that this error states that the body of largest won't work for all possible types that t could be, because we want to compare values of type t in the body. We can only use types whose value can be ordered to enable comparisons. The standard library has partial odd trait that you can implement on types. To fix that, we can follow the help suggestions and restrict the types valid for t to only those types that implement partial odd. Then the listing will compile. Okay, because the standard library implements partial odd on both i32 and char. Consider restricting type parameter t with trait. Okay, so I think I need to start writing some code because it's probably getting a bit boring. Oh, come on, wait. Okay. Let us okay, this is fine. Oh no, wait. Yep, it's okay. Okay, so let's do we have a largest function? Yeah. And of course it will take input. Yeah. And let's say this is a let's say this is like so, and it returns for us a reference to an I32 value. I think this is like this is the concrete implementation for the I32 one that we saw earlier, right? And then we had the implementation, right? So we received maybe we can copy it, but I also want to write some code. Yeah. So anyway, we just get the first one, right? So we can say let largest be input. So we need to get the first value here, right? Or maybe like even either a reference to that is okay or whatever. Yep. And then we iterate over this. We can use a for loop, right? Or we can, yeah, we can just use a for loop easily and say for item in largest, no, in input, yeah. And then we say if largest is greater than item, yeah, then we want to say that largest becomes item, right? But we are now dealing with reference and actual values. Let's see. But in any case, largest has to be immutable because we're changing the value, right? So yeah. And then I think that's it. Yeah. We can go to, yeah, it's complaining. Nice. So it's expecting a reference to the type, and we are giving it a different thing. We're giving it an actual I32 value. So I guess here we can, I don't know, we say reference. Oh no, it's like 2. Wait on. Do I need to say I want to iterate? I don't need to do that, right? Oh, I guess the problem is that we did not return a value. I don't think I need to return anything, but anyway, let's go and return. I said we could change latest to, yeah, yep, reference, yeah, reference. Okay, let's return largest here first of all. Yeah, mismatched expected reference, and we have the actual value. So yeah, you're right, we need to say that this is a reference. Okay, takes care of it. But what happens if I don't do iterate? Yeah, should be fine. because it's already an array. Okay, so now this is our concrete type for this. Now we need to do the generic implementation. Yeah. Um, so we have a function largest generic. This is function, but first we would need to siaran GPT. Is that? I don't know what kind of question that is, but anyway. So yeah, largest generic. Um, I don't know if siaran GPT is human. So we have to first define the generic type we want to use. So in this case, it would be like maybe this. It's just the same thing, right? So and then this would then be reference to that type. So we can now use the generic type. It's just like the you're asking when it first started. Your name says GPT. Okay, so maybe you're human, or I don't know if you're using my voice. But anyway, I'm expecting bots. But anyway, you're learning Java currently, and on classes and objects, and if and feels dumb. Oh, that okay. You're a real person. Okay. Maybe I should even do this. Okay. You're asking if I found it difficult to understand programming in the beginning. I don't really know. Like it's been a long time. I think I've been coding with different languages for long now, so I don't really. Maybe when I was younger, maybe in the beginning, I guess. Yeah. So you're learning Java. I'm just getting interesting. Let's keep on with generic version. Okay, cool. Okay, let's write the generic implementation. So yeah, so we have the input. So again, the concept of generics here is that we first have to, just like we do with input parameters, we have to first define the type because it's not known. So that's why we defined it here, and this is the syntax for it. And then we can use it, right? So we can now use a type, and then we can, again, this is about using it. We can then also specify the output type, which again is our generic. So similar to the concrete implementation. And then we do that as we have done the other one. Again, largest, and we say it is a reference to the first element in the input. Wait. Yeah. And we again iterate over this for item in input. So this is where we're going to have that problem that we saw in the book, right? So which is the compiler complaining that it doesn't know how to order this, because I think the concept is called a trait bound. We have to use a trait bound to specify, to restrict types that can be compared using the partial odd traits, but we'll see that now, I guess. If it's that, then we do largest equals item, and then we have to return largest. Yep, and now it says binary operation greater than cannot be applied to type reference of the generic T. And it tells us what we should, it's suggesting to us what we should do. It says we can, where is that? So we should consider restricting type parameter T with the partial odd trait. So, but how would we do that? So I think if I recall, you can use like there are two ways. You can I think you can do it like so. Is it partial odd? This is probably one way, right? Yep. Yep, exactly. So this, when we do this, this is, it's called a trade bound, but we will see that. I just remember that now. So this is like specifying a trade bound. What this means is that this largest generic is a function over the generic type T that implements the partial odd trait. So it only works for types that implement partial odd. We'll check on in reference now what partial odd is. And there's another way to do it, because this can get very long and then it's messy. You wouldn't even know where things are. But the other way is what ICS Boix is suggesting, which is using where, which I prefer as well. And I think that is done in the return type, right? So I think it's written like, is it like so? Where T implements partial odd, if I'm not wrong. Yep. So this is the second way to do it. And with this, we can then we can use this. We call this in the main function by creating an array, right? So let input be an array of types this, maybe and then, so that's input is an array of type I32 that has wait, it says what default is it for the array syntax again. Why is this not supposed to be length, or what? Missing a comma, exactly. Here's the comma. I was wondering why that is saying, oh yeah, here. No wonder it's saying 3. I got me stunned. I was like, I don't have 3 items there. Yeah. Thanks. Yeah. Okay, so and then we can yeah, so let largest be, yeah, be largest generic. Let's use the generic one. And then we give it a reference to input. Yep. And then this would be our value. So okay, so I think we are, what is this? Largest generic. Why is it says it's -5? What do we do? If largest is greater, oh no, we we mixed it up. No, so actually we should be comparing the other way around, right? It should be that if item is greater than largest, yeah. Wait, what's, oh yeah, we changed the wrong thing, right? Why isn't this one? Yep. Okay, so now we got it. Okay, so let's look at the partial odd trait even, because Hey, thanks for. I think someone followed. I don't know. Oh, there was something. Yeah. So the partial dot trait, it's in the STD comparator, I think, module. It's a public trait that is defined like so. And look, it's even also using the generic, right? So there is RHS, which is like right hand side, I guess, and it says it's equal to self. Um, and this, okay, well, this syntax is a bit um different. It's different. I mean, this is partial equals here. This doesn't mean that it's wait, hold on, let's see. No, yeah, that doesn't mean that it RHS equals self is just the default, right? Okay. Okay, so the default. But what about this, right? So how do you have what is this syntax here? I mean, I know that for generics, if you say colon and then this like inside of here, like from here, and it means that it implements this. That's a trade bound, but this is not a trade bound written like this. So the trade bound here is this. So where right hand side partial requires partial equals. So that's how you say that. Trait inheritance, right? Okay. Okay. Trait inheritance. So it requires partial equals. What does that mean actually? So this trait you created now, but it inherits the what does it inherit? It inherits the public function, the functions of the partially called trait. Is that what that means? Partially called trait. Okay, it just means right inside itself. Partial ORD builds an extra capability on top of partial equals. Okay. Let me get rid of this first. Okay, so you have partial equals has the functions equal, so self and other right hand side, and it does a bool, not equal, right? And then now partial ORD. Okay. So any type that implement ORD also has to implement equal. ORD. Okay. But it has implements ORD. Oh wait, this is what you mean otherwise. And then where is, let me see this. This is the odd trait, you mean? Okay. Yeah, you mean partial ORD and partial equals. Right. Okay, let's see the partial ORD. It has this is the required methods. So you have partial compare. It takes itself and the right hand side and then returns an option of ordering. And the provided methods are less than equal, greater than equals. So these ones, I guess these are provided, but if you implement partial OR, then you have to implement the partial compare yourself, I guess. The most basic level of comparing is comparing for equality. Exactly, yeah. Partial adds on the ability to compare for less, greater. Yep. So you get those out of the box, right? So if we look at partial equals trait, it says this is the required method and this is provided method. What does that mean? What does required method, and I mean, I would expect that provided method means oh wait, look, it also has like ellipsis here. Doesn't mean like it has the implementation for you, but you when you implement these traits, you have to do this yourself, right? So you have to. How does that work? Okay, let's see. So the trait comparison allows the equality operator for types that do not have full equivalence ratio. Implementations must ensure that equal and not equal are consistent with each other. Okay. The default implementation of not equal provides this consistency and is always sufficient. It should not be overridden without a very good reason. Okay. Yep. Yeah, let's see the source. Right. I think that's what I was expecting actually. So this is the default implementation of not equals, which should be sufficient as they mentioned. But equals is what you would have to provide. There's no default implementation for it. Yeah. Okay. So if partial odd or odd are also implemented for self and RHS, their methods must also be consistent with partial equals. Okay. Let me see. I want to see. Okay, how can I implement partial equal? So so I just want to look at one example implementation. Yeah, I've like I said, I've done that sometime before. Yeah. So, but yeah, we're doing like a revision of these things just to like go over it again. Let's implement partial equal for your own type. Actually, the book format is a good example. Yeah, okay. Yeah. So I wanted to see this. So I have a book format that has these. I have a struct book that has an ISBN and a format. Then we want to implement partial equal for trait. Partial equal for book, yeah. And yeah, this is the required one. That's why we have to implement it because the not equal has a default implementation, so it will work by default. So we take the other book and then we do the comparison with this. I mean, this is how we want to do it. It can be another way anyway, but this is what we do here, and then we return the bool. Return a boolean. Yeah. So we have book 1, book 2, book 3, and we are doing the assert. Okay. It doesn't make sense for to implement partial odd for book formats, but partial equal does make sense. Partial odd, that is you mean partial odd is for sorting or for ordering, you mean, yeah, in this case, right? Yeah. But partial equal makes sense. Yeah. Unless you want to unless for the book struct you have things like the dimensions of the book or maybe weight, and you want to order in the shelf by size, weight, and other things, right? Okay, yeah. Then even at that, you would still need to. I mean, it's the partial order you would still need to implement. Yeah, in this case, there's no natural ordering between book formats. Yeah, but isn't that what you want to implement? It's just like saying you want to implement sorting for a generic type that you have, right? Or some custom type you have. You can implement it even if it doesn't have natural ordering, right? Or is there a different um, trait you'd have to implement for that? I guess you can use um, partial order for that, or like something that implements to a Java. I'll say comparable or something, right? Okay, so I think we've already seen that one. Okay, yeah, look, it's even comparing two different ones. This is like equals. Is it not? Oh, no, that's still equals. Yeah, okay. I want to see the just one look at the partial order here. Okay. Mm, I mean, you could choose an ordering, but this seems like a good example of a type for which there is no obvious natural ordering, and you might choose not to implement partial order. Yeah. Okay. So if we go back to partial order trait, we say that it's inheriting from partial equals. Thanks for yeah. Okay. Yeah. And then the required method we have to implement here is the partial compare. I didn't want to do that. Go back. Yep. Partial compare, which compares with the right hand side and then returns an option that is has ordering. Ordering is an enum, I guess. So what is it? I mean, I'll open that up in a bit. But so the methods that are provided for us are less than equal, greater than equal, or greater than. And okay, interesting thing is that these less than equal, greater than equal, or greater than methods can be called using these operators. Okay, convenience, nice. Okay, show me an example. Derivable. This trait can be used with derive. Okay. Hmm. When derived when derived on struct, it will produce a lexicographic ordering based on the top to bottom declaration of the struct members. Okay. When derived on enums, variants are primarily ordered by their discriminants. That's like, by that you mean how you place them. Yeah. But for structs, graphic ordering based on the top to bottom declaration of the structs members. Okay. Yeah. I mean, that's really convenient. Secondarily, they are ordered by their fields. That's for enums. By default, the discriminant is the smallest for variants at the top and largest for variants at the bottom. So here's an example. So we have um, we use the derive annotation for partial equal and partial odd. So basically, we get the default um, traits on this enum. We have top and bottom, and then we want to assert that top is less than bottom, or is, in this case, is smaller than bottom. So based on what we saw here, that by default the discriminant is the smallest for variants at the top and largest for the ones at the bottom. Okay. Yeah, that is true in this case. Good to go. See you next time. Yeah. See ya. I says Boix. Thanks for stopping by. Yeah, I'll be wrapping up in a bit anyway. Yeah. Okay. However, manually setting discriminants can override this default. Okay, like so. So bottom less than top. Yeah, I mean, I'll choose to be explicit about it. To be honest, if I was doing this, if I wanted to order. Yeah. Okay. How can I implement partial order? Yeah. So let's see an example. And wait, let's see. Um. So it only requires partial order only requires implementation of the partial compare method, while the others are generated from default measures. Yes, we saw that. However, it remains possible to implement the order separately for types which do not have a total order. For example, for floating point numbers, not a number less than 0 is false, and this. Okay. You do not have a total order. Yeah, so I think this is the kind of thing I was talking about, where you are comparing persons, or like a book um that has like dimensions. You can say you can order by weight or by dimensions of the book, maybe for some kind of for packing them into boxes and those kind of things, um, or even arranging on a shelf. Partial requires your type to be partially equal. Yes, if your type is odd, you can implement partial compare by using compare. Okay, so we have a struct like so, and then wait, yeah, we have a struct like so, and then we implement partial odd for our struct, and then we implement the partial compare. Okay, so we just call the compare function on self on person. Why is that on person? Oh yeah, because we implement odd trait here. Okay, but what if we didn't want to implement odd, the order? Okay, so because we implement the odd, then we can, yeah, then we can, wait, we implement odd. It has a compare function, actually method, yeah. And then we compare the height, and this gives an ordering, which we had to check what that actually means. But then we can, for the partial compare implementation, which gives us an option, yeah, of ordering. Okay, so we just call that, right? Okay, and we also implement partial equal here because it has to. Oh, this is by hand. We're doing all this by hand. Okay, so because it doesn't have, because person doesn't have a natural ordering, so we have to do this. So partial equal, we implement equals, which is we're comparing the heights for this, but we implement equal for person. Why is this necessary? To give us, oh, I guess it's to give us uh, the the other trait methods that are available on equal, right? Because yeah, okay, so we get it, yeah, and then we can use that. Why wouldn't you try that? Changing example to not implement odd. Yeah, let's try this one. To not implement odd. Okay, then if we don't implement odd, then we can do it with We have partial odd, and then we have partial equal. Yeah. Okay, let's see. I can just, what does this do? Copy. Okay. Wake up. Okay. Mm, yeah. Okay. So let's. Oh no. Let's copy that again. Okay. So we have. Yeah. We bring ordering into scope. We have person. We have partial odd, and then yeah, I was talking about this one here. Okay, I was talking about why this is necessary, and that's just because um we need it needs to partial equal. Let me even see. Yeah. Why did we need equal again? We already have partial equal. Why is this necessary? The dog for equals explains it. Let's. Trait for comparisons. The primary difference to partial equal is the additional requirement for reflexivity. A equals A. A type that implements partial equal guarantees that for all ABC, okay, all of those. Yeah, property cannot be checked by the compiler, and therefore equal is a trait without methods. Okay. Right. Okay. Okay, that's it. So basically, you're implementing equals. Yeah. It's just that it has no methods in this case. That's it. There are no methods. It's just gives us these guarantees here. Okay. So we actually implement equal for person. Okay. But um but then what I'm asking here is why are we not able to just use partial equal? Wait, let's go and see that. Again, partial equal, does it require equal? No, it doesn't. You can just use partial equal for some things, not for you can just use partial equal for some things, not for others. Like I don't want this, so what is gonna be wrong if I don't do that? So the trait bound person as he compare is not satisfied. Okay, so you cannot compare, but I have partial equals here. HG hash map lookup requires equal. Yes, but for this example itself, um, is wait, let's see. Oh, is it because of the usage of odd requires equal? Right. Okay. Because we implement odd. Okay. Then that makes sense actually, because I was like, where exactly is what exactly requires it? Yep. Okay. Yeah. So it inherits equal and partial odd. That is why. Yeah. So we needed to have partial odd here. Okay, then that makes sense. If you don't implement equal, you can't implement odd. Exactly. Yeah. But then, hmm, if we used the derive attributes, are we able to do that with this? Can we? How does that even? Let's. What if we wanted to use the derive attribute um for person, and then say we wanted to, okay, we should try removing equal and odd. And how do I do? Yeah, I think in Rust I can do wait. I think we can do a multi-line comment, right? How does that even work again? I think so, right? Should be something like this. Yep. Probably it's even like this. Okay. Okay. It says empty line. Oh, this is docs. Okay. I mean, we should do it like this. Okay. Sweet. So we remove odd and equal traits. So what do we want to so partial equal and partial odd that we have here. So what do we want to do? But we see that method compare does not exist for this, but it's straight bounds where. Okay. What I was looking at is if we can actually use the attribute as well. So I don't know. I'm not sure we can use the. How does the attribute look? If I think they usually would provide. Does it say derive macros? No, this is just the. Ah, yeah. So I can use the derive. The derive macro with the. So now you can just copy the body from compare into partial compare. Um, okay, so you mean, all right, so that we do this. Yeah, we can do, okay. Mismatch. Yeah, this, oh yeah, sum, right? Yeah, this is an ordering, it returns. Yeah, that's actually something that I need to see what that returns. Okay, and on we have this on U32. We have the wait. What was that we said? Primitive types, numeric primitive types. I think they implement. Let's see. They probably implement ordering for this to work. Yeah. Okay. But let's look at what we're doing actually. So we implement partial ord, and yeah, the only thing the requirement for partial ord for us here is just partial compare, and partial ord needs partial equals, right? Yeah, integers implement ord, floats implement partial ord. Okay. Again, partial ord. Again, partial ord. Yeah, requires partial equal. Yep. I think it still needs a little bit of getting getting used to a bit, but yeah, I think I get the basic concept. So that's why we need partial equal here. Yeah. Okay. I get it. But if I didn't want to implement this by hand, how do I use a macro for it? I have, so let's say this. I want to change this to have just the. I can tell all this complexity within partial is because of many years ago. The IE standard made some unfortunate choices about NN. Right. Yeah, because yeah. So um so I wanted to see, so we, for us to implement partial ord, we just need partial equal here. That's all we need. Now how do I get partial equal without writing this, like with an attribute or with the macro? Let's see. So it's partial equal. We start with partial equal and look at what the macro looks like. It's was already there actually. The macro is derive macros. Derive macro generating an implementation of partial equal. The behavior of this macro is described here. Yes. So I want to see what the default is. Wow. Okay. Um, I see. So this is for U8, for example. Yeah. Right. So it means partial equal. Right. This is how it works. So standard library gave us these ones. Makes sense. But we can also have it for. Oh, you said derive will give us lexicographic ordering only. Derive partial equal means all fields must be equal. Yeah, I think that was also, they mentioned that somewhere. But I want to see the implementation. So this is my generic type here now. It's my struct. Yeah. And here, how does that look? Where is it? Which one is it? I think it'd be a generic T. Multiple types. I want to see the source of it. This is phantom contact variant. Interesting. They even have it um for a tuple of n values. Okay, I guess it's there, but I probably have to find out maybe later. But definitely, I wanted to see what it looks like because you mentioned see derivable in that doc. Um, derivable. Where's that? Derivable. I don't see it derivable here or. Oh yeah, here you mean derivable? Yeah. Okay. Yeah, this trait can be used with derive. Yeah, when derived on structs. Yeah, I think we also read this before. On structs, two instances are equal if all fields are equal. Yep. And not equal if any fields are not equal. When derived on enums, two instances are equal if they are the same if they are the same variant and all fields are equal. Okay. Yeah. So in this case, for us here, what that means is when we do a partial equal, it will compare the ID, the name, and the height. So all fields have to be equal for this to be equal, but our implementation just uses the height. Okay, that will be the difference here. Okay, and yeah, so we've seen that one now. And how does that look for partial OR? Oh, come on. I think we just go to the variable as well. Okay, cool. When derived on struct, it will produce, this is what you're saying, lexicographic ordering based on the top to bottom declaration order of the struct members. What were we doing? Okay, so wait. Okay, let's do this. Yeah, because these are equivalent. So in this case, we can create some persons. We have a struct here. Click the lexicographic link. Okay. Lexical order, dictionary order. Yeah. Yeah, that's what I wanted to try out there. I want to try it out on the by creating persons and then using the partial order. Let's order them and see, right? So what's wrong with this keyboard? Okay. Yes, back. Okay. Um okay, so I think we can do like new, right? And then say wait. Yep, and then do new and give me self. And this wait, I will pass some values to it, right? Say I need to pass an ID. Wait, sorry. 32. I need to pass a name. I need to pass a height to it, and then it's going to return me why wouldn't this work? This should work. What associated function using arrays? Okay, of course. Yeah, so now I want to create persons. By the way, I can put all of this in the module. But anyway, let persons wait, let's do this. Let persons be I'm gonna say from or no worries, let's just put that into let's do this. So we need I just want to create multiple persons. Or maybe actually we should do person new. Right. I know it's okay. Okay, so we have feel free to have an array if you like. Okay, let Alice be that. Okay. Right. Okay, so oh yeah, this needs to be string from I actually find this string from very annoying, to be honest. Is it now okay? Okay, now it is. So we have three persons, and I deliberately made the first and third the same, right? And now we want to see how comparison works for this. Yeah. So um, and we can do. By the way, I guess we can sort this, right? What do we have in what do we have in what do we have in compare for in the compare module for us to do sorting? Do we have a sort function? You could change person to hold static lifetime, reference static lifetime, or you could have function new to the conversion. It's a method on slice. You can do we can do persons dot sort. Okay, so sort is on slice. Yep, and again it's where t, which is a generic, but this doesn't define generic. How is it using it? This is pretty interesting. Public sort. How does it? Oh wait, it's on slice. Slice is also a generic. Like how do, what is where is t defined? How is it using it? It's in the implementation. Okay, right. Yeah, because it's okay. Yeah, so it was created here. Okay, makes sense. And it implements odd. I mean, where t is an odd, which is okay. Yeah. So wait, let me go back here. Yep. Sorts the slice in ascending order, preserving the initial. Okay, so we can do persons of sort. Yeah. And then what does that even give to us? Okay, it sorts. I think it's on the mutable. Wait, does it? How does it even work? Let's see. Oh yeah, mutable takes a mutable reference. So sorts. So person has changed already at this point. So this wouldn't even work because it needs to be mutable. I mean, this needs to be mutable for that to work. Is it not? But anyway, let's um the trade bound pressing the OR is not satisfied. Hmm. Yeah, because it needs to be an OR. So we cannot sort this. So this is relevant for us. And this now, yeah, and this requires equal. So let's just put that there. And we can also do this now. Okay. And yep, mutable. Okay, that's what you were saying. So it has to be mutable. Yeah. So now when we sort, persons has changed. So let's do persons dot um ter dot um map or no like um Why don't I have access to that? I wanted to print values from the person, like, or return. Okay, you say we can just print persons. But person doesn't implement. Okay, we'll have to implement display trait, I believe, right, for that to work. We can't just do that, right? So let's see, print line. Yeah, we have to implement derive, and I guess display trait as well, right? So that would be um, no, what's wait um where's my oh yeah, yep, okay. You can't derive display. Why can't I do this? Yeah, it doesn't implement FMT display. Now if I do if I do this derive debug, yeah, still doesn't implement it. I see. Yeah, because this, what I'm doing here is display. I don't need debug, right? That's, yeah, exactly. And this uses display. Uses debug, not display. I see what you mean. Okay. Okay. And for display, I have to implement that manually, I believe, right? There's no. Let me just check that 1 second. For me, I think it's usually just solidifies my understanding of things when I just check this display trait, FMT display. That'll be on derivable. Doesn't have it, right? That's what you mean. Derivable macros. Debug. Yeah, okay. Derive macro generated in implementation. So again, the way that can, well, let me go back to debug. But there is no, where are you? It says cannot be derived on that page. Where did it say that? Display. Cannot be derived. Oh, display is similar to debug, but display is used for user facing output. So it cannot be derived. Yeah, that makes sense actually. That makes sense. Again, the derive trait. Yeah, this question mark formatting. Debug should format the output in a programmer facing debug context. Okay, generally speaking, and when you should just derive a debug implementation when used when used with the alternative format specifier, this the output is pretty printed. Okay, so we can do it like so. If all fields implement debug and derive for struct to use the name of the struct, then this, then a comma separated list of each field of the fields, yeah, and debug value, then that's closes. Okay, for a norm it will be the name of the variant, and if applicable, this, right. Example, you have this. Okay, so we can use the macro, in this case format, and then we have the variable we want, and then we use the question mark operator to say it's debug trait we want to use. But what else? Or you implement it anyway. But there was something else you were showing, which is, yeah, which is what you suggested to do, right? But what is, yeah, what I want to get is what the hash, what is that? Oh yeah, this is what you mean, what you were talking about here. Debug implementations using either derive on the debug builder API on formatter support pretty printing. Okay, this is what you were referring to. Okay, so when we use this, then it will do pretty printing. Yep. Okay, so I got it. So here we do like so, and yep. Yeah, exactly. Okay. So we have, yeah, James 158, James 158, and then the other one was moved down. So we have the same value appearing twice here, and then the one with 168 or 162 rather moved down below after we did sort. And sort is only available because we have equal, trait, partial equal, and ORD implemented here, and we are only comparing with the height in this case. Same thing if I was doing height and name, or height and something else. Okay, what if I was doing this with, yeah, anyway, I think we get the concept. Do I have reverse? What is reverse on? Is that also on sort? Is that on the slice as well? Slice reverse. Reverse is the order of elements in the slice. Yeah, but that no, that's not what I want. I want a sort, but on the sort is ascending. I mean sort slice sort is ascending. I want it descending. Can I get that? So, or is it sort by? Yep. Is it? Yeah. Compare. Okay. Sorts the slice in ascending order with a comparison function. Okay, I have to provide the function here. Yeah, we can do that. Oh, this is the reverse sorting that we're trying to do. Yeah. Okay. 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 And it works in this case because, again, because those are implemented. Um, yeah, I think it's AB in this case. Um, yeah, we can do this. What? Mismatched types expected. Um, reference to string, found string. Um, what? Mismatch types. So is it in the compare? I guess the problem is with the compare, right? Found string. Well, I can do. Does that give us? Yep. Yeah. This keyword is not sensitive. Okay, so now we have Jones. Yeah, so it reversed it. Then we have James and then James. Okay. All right. So I think, yeah, this is pretty interesting. Yeah, pretty interesting. Keyboard is using QMK. No. I have this. It's a custom build split. I mean, I was just trying it. That's also why I'm typing Word. So yeah, but I noticed that the space, one of the keys is it's not very sensitive. The space one. So yeah, I'm probably gonna change the connector there. Yeah, but later. You bet it's in QMK. Okay. Yeah. I can check that too, but I'm not sure. I don't think it is. I think I recall reading that in the docs, the guys who assembled this one, they had mentioned not that. Yeah. Okay, if I drop a link. Yeah, sure. Yeah. Cool, yo. Um, why is it? It's not what it's a pause or what? I can't even get to it. See, interesting. I think this chat is slow, but anyway, I can try to. Is it now there? It's not there. Do you see it? That's interesting. Okay. Rust curious. Okay. Destruction enums. Okay, nice. I'll uh I'll check it out. Yeah. Okay. Yep. And Yep, I will continue later. Later today, I believe. Yeah, but I think now that it's still sun, I need to go get some sun today. All right, thanks. Thank you very much for stopping by. Yeah, and I should also give you a follow actually. Hmm. Yeah, should do that. Yeah. All right. Thank you very much. Then yeah. See you later. Yeah. All right. Bye everyone.